This video is an example of a chi-square goodness of fit test. And the statistic we're going to be using is this one, and here's the formula. I went over it in the last video, but we'll go through it again when we work out the formula. We're going to actually do the second problem now, which is on the bottom of the worksheet. So number 2 is a professor in the psychology department would like to determine whether there has been a significant change in grading practices over the years. It is known that the overall grade distribution for the department in 1985 had 14% A's, 26% B's, 31% C's, 19% D's, and 10% F's. A sample of n equals 200 psychology students from last semester produced the grade distribution below. Do the data indicate a significant change in grade distribution? Test with alpha equals 0.05. So we can already see that there's a difference between this one and the last one. The last one, it was one of those no preference type of null hypothesis. This is one of those no difference from a known population type of hypothesis. So they already told you what a distribution was in a previous year. So we're going to compare what we got, our observed samples, and then see whether they are significantly different from those proportions here. So yeah, let's go ahead and get started. So the first thing that we're going to do, as always, is state the null hypothesis. So we're going to make little boxes here. There are 5 categories of grade. So we're going to make it a little bit longer. 1, 2, 3, 4, 5. Yeah, 5. Okay, so the A's had 14%. So we expect 14% A's, 26. 26, 31, 19, and 10%. Okay, so this is what we're expecting. Our alternative hypothesis is that at least one is different. So at least one is significantly different. So the second thing we're going to do, and we're going to do on the corner here, is just do a little picture just to help us with the intuition of the process that we're going through. And so we need to find what this cutoff value is that separates the rejection from the non-rejection region. So for that, we're going to need to know the alpha level, which was given to us as 0.05, and the degrees of freedom, which for these sorts of problems is the number of categories minus 1. So for this one, we have 5 categories, so that's 5 minus 1, so our degrees of freedom is 4. So now what we're going to do is we're going to look up in our key distribution table, and we're going to look at the top row and scan for the alpha level that we were looking for, which is 0.05. That's the 4th column of numbers. And our degrees of freedom was 4. So we're going to scan downward until we get to 4 along the degrees of freedom here on the leftmost column. So our cutoff value is going to be 9.49. So this value here is 9.49. When we calculate our statistic, we need to have a value that's greater than that in order to be able to reject the null hypothesis. Okay, so now that we've done that, we can actually, our third step is to start calculating. So, well, first what we're going to need to do is figure out what these expected frequencies are. So we're going to have to multiply you know, the proportion for that particular grade times the sample size to give us the specific numbers that we want in here. So notice that these could actually be decimals, so they don't have to be whole numbers. But basically, the first one here is going to be 0.14. So that's 0.14 times 200. So that's supposed to be 14%, right? So if you punch that into your calculator, 0.14 times 200, you'll get 28. So for the second box, we're expecting to have 26%. So the second box is 0.26 times 200. So if you type that into your calculator, you get 52. And then this third box similarly is 31%. So 31 of 200 is 0.31 times 200. So 0.31 times 200 is 62. 19 of 2% of 200, that's 0.19 times 200. So that would be 38. And then lastly, we have 10% of 200, which is 20. Okay, so these are our expected frequencies. Now we're going to go through the process of applying that formula to each of these categories, right? Taking the difference and then squaring that and then setting that over the expected frequency for each category. Or we're going to iterate like that. I'm going to go a little bit faster on this one. Okay, so if you remember, our formula says to do what I just described, to take the observed frequency and expected frequency of each group, square it, set it over the expected frequency of that particular group. And that's, you know, and then make those terms for each group and then sum those. So I'm gonna go down here and I'll actually do the symbol first. So we're gonna do FO of the first group minus FE of the first group. Square that, set it over FE of the first group. And then we're gonna add that to, I'm gonna make them smaller, FO of the second minus FE of the second. Square that, set it over FE of this second. And then we're going to do the observed frequency of the third minus the expected frequency of the third, square it over expected frequency of the third. And we're going to do observed frequency of the fourth minus expected frequency of the fourth, square that over expected frequency of the fourth. And then we're going to do these are getting kind of long. Expected frequency of the observed frequency of the fifth, I'm sorry, minus expected frequency of the fifth, square that over expected frequency of the fifth. So hopefully you can see those numbers here, but you should get the point symbolic of the symbols. So we have 1, 2, 3, 4, 5 terms corresponding to the 5 categories. So now we just have to plug those numbers in and just figure out what the calculation is. I'm not going to go too in detail of these. I'm just going to, I'll fill these in, and then I'm just going to do the final answer on my side on the calculator over here, and then we'll compare that to the cutoff value. Okay, so that's 32 minus 28 squared over 28 plus 61 minus 52 squared over 52 plus 64 minus 62 squared over 62 plus 31 minus 38 squared over 38, 12 minus 20 squared over 20. So now notice that now these look different than our previous example. So here, now we actually have different expected frequencies for each category. So we have a particular number for each term. So you can see here, this is me just filling in the numbers from the table. So I'm not going to do these other intermediate steps. You can see what these different terms are here. I'm just going to punch them into the calculator. Okay, so let's do minus 28. Square that. So these can get quite time consuming. They're not difficult, they're just, you got to keep track of your numbers. So picking the good calculators, a good idea. Minus 52, and then that's over 52. I like using the Desmos calculator for these kind of problems, because I can see all the compartments, and I can separate different chunks of the terms. 64 minus 62. 62 over 62. And you have 31 minus 38. 38 over 38. Okay, almost done. On the last term, so we have 12 minus 20. 12 minus 20 over 20. Okay, so I'm getting, as my final answer, 6.683, so 6.68. 6.68 is our chi-square statistic. So you can see here that we don't actually land in the rejection region. Our number is not greater than 9.49. We're probably over here somewhere. 6.68. So here, also in this situation, we would fail, put this out of the way, fail to reject the null hypothesis. So here we can't say that things are our distribution is different, significantly different than it was in 1985. So the proportion of grades is probably still similar to 14, 26, 31, 19, 10.